Hi everyone, this is Professor H. Rahman from Agricultural and Food Engineering Department from IIT Kharagpur. I welcome you all to this NPTEL certification course on traction engineering. This is lecture 13 where I will try to cover how to find out motion resistance of a truck. Truck and wheel. These are the two important traction systems which are used for developing traction in case of a tractor or crawler tractor or in case of high HP tractors. So the concept will be how to find out motion resistance of a truck. That means how much force is required to tow this truck. So the truck is basically assumed to be similar to rigid footing, and the truck, if you look at the right side figure, there I have indicated a truck. So it will have certain amount of logs, but the logs are not that prominent as in case of a wheel. So it has certain width which is not visible in this diagram. So in the cross section I have given width as B and length as L, and it will be carrying certain amount of weight W. And there will be rollers to give tension to this truck, so that during engagement with the soil, that means during shearing action which the truck is going to create during operation, so the belt has to be in tension or the truck has to be in tension. That's why you have provided these rollers. So here what we have assumed is the normal reaction during the interaction process with the soil. The reaction will be exerted on the truck by the terrain, and here we have assumed that the pressure is uniform throughout the contact. That is an important assumption, we can say. And the normal reaction exerted on the truck by the terrain can be equated to that beneath a sinkage plate at the same depth in a plate sinkage test. So this is very important. So the normal reaction will be equal to your pressure beneath a sinkage plate which is at the same depth as that of the depth at which the truck is moving. So the assumptions are the truck layer doesn't tilt when in operation. That is number one assumption. And the load on the truck is uniformly distributed. If it is not uniformly distributed, then the reaction which you are getting at the soil truck interaction surfaces, it may not be uniform. So that's why we say load on the truck is uniformly distributed and the truck layer doesn't tilt during operation. The contact area, very simply I have done it, the length and this is the width. Length and width multiplication will give you how much will be the contact area. And the force which I have indicated F here is the thrust force. But we are not interested in developing thrust force now. We will be discussing about that little later. So only what we can discuss is how much is the force required to tow this forward. So we know that in a plate sinkage test, P is equal to kz to the power n. If plate has to be sunk into a depth of z0, then pressure at that depth will be equal to kz to the power n. Or in other words, z0 will be equal to P by k raised to the power 1 upon n. Okay. Now, P, as you have assumed that the pressure is uniformly distributed, that means load is uniformly distributed. So, P I can write as W by B into L, because B is the width, L is the contact length. So, weight divided by area, that can be denoted as pressure. Now, I substitute here. So, this becomes W by B L K raised to the power 1 upon N, where P is the normal pressure, W is the normal load which is acting on the truck, then B is the width of the truck and L is the length of the truck. in contact with the soil. Now, the work which is done in compacting the soil along the track length L, and it will make a rot of width B, because wheel width is B. So this is your width B, which I denoted as B. So it will make a rot in the bottom surface when it is in contact with the soil. So that area is B equal to B into L. Now what will be the work done in making a rot of depth Z0? So work done will be equal to pressure into area, that will give you force which is applied. So B into L, then P. How much it has gone? Z, to depth Z, which is indicated here, sinkage. So this has to be integrated from 0 to Z0. If Z0 is the maximum sinkage, then we have to integrate it from 0 to Z0. So this will becomes B into L B into L, instead of P I can write Kz to the power N, okay, into dz. So this becomes B L K Z 0 raised to the power N plus 1 by N plus 1. That means work done is a function of what is the area, what is the sinkage, and what is the exponent of sinkage N. So soil condition, contact area, and K is the modulus of sinkage. Okay. So now if you substitute for Z0 we have derived as W by BLK upon 1 upon N. So if I substitute for Z0 here, so finally work done will be equal to BL N plus 1 into K to the power 1 upon N into W by BL raised to the power N plus 1 by N. Okay, this is the work done expression. Now, if I want to tow this track to a distance say L in a horizontal direction, and then the work done in towing this track by a force which is called towing force, that will be equal in magnitude to the motion resistance due to torrent compaction. So let me repeat again. If I want to tow this track to a distance L by applying a force which is called towing force, then that towing force will be equal in magnitude to the motion resistance. Why? Due to compaction of soil. And if that is so, then I can write work done in compacting the soil will be equal to your towing force. Towing force, if you denote it as R, it has to be towed for a distance L. So this will be the expression. Work done in vertically compacting the soil to a depth Z0 will be equal to the towing force and the distance up to which it is towed. So with this background, we have to now find out what will be the rolling resistance for a truck. So motion resistance of a truck will be now R into L will be equal to B into L divided by n plus 1 kc by b plus k5 raised to the power 1 upon n into w by bl raised to the power n plus 1 upon n. Now this L is the contact area. This L is the contact length, this is the contact length, and this is present in both the left hand side and right hand side. You can delete this one. So finally you will get an expression: rolling resistance is a function of section width B, that means width of the contact area, that is the track width, and W, what is the weight coming? It is the function of soil, that is Kc, modulus of sinkage, exponent of sinkage, then okay, this much. Now if I take B out of this bracket, then finally this is the expression. Now it is for our own knowledge that the expression which you got for track, the expression which you got for towed wheel, the rigid towed wheel, and the expression which you got for pneumatic wheel, how they are different or how they are similar. So to verify that one, now I will try to find out and compare what is the difference existing there. So this is the expression for track. R is equal to B upon n plus 1 into Kc by B plus K5 raised to the power 1 upon n into W by BL raised to the power n plus 1 by n. Now for a pneumatic wheel, R is equal to B into P ground pressure, that means ground pressure raised to the power n plus 1 by n divided by n plus 1 into Kc by B plus K5 raised to the power 1 upon n. Now if you look at these two equations, what is the similarity? B is there in the numerator, B is there in the numerator, and this n plus 1 is there in the denominator, and this k, Kc by B plus K5, it is there both in denominator of track, denominator of wheel, and this is raised to the power 1 upon n. The only difference is W by BL, and the ground pressure also in case of a elastic mode of operation. For a pneumatic wheel, ground pressure is nothing but weight divided by the contact area. So contact area you have taken as length of the flat portion LT into section width. So W by L2 into B. So that means more or less they are similar. Then the question arises, which one will give you lesser rolling resistance? When they are carrying the same parameters, nearly same expressions, because PGR is raised to the power n plus 1 by n, W by BL is also raised to the power n plus 1 by n. Then the question arises, which one will give you lesser resistance and why? So if you think little bit, this BL for track and BL1 for wheel, they are not same. Usually the tracks are longer and width of tracks are longer, whereas the section width of wheel or contact length of flattened portion of the wheel, they are much smaller than the contact length and section width of track. So that means this area of the wheel is, if you denote it as area of wheel and if you denote it as area of track, so area of wheel is much less than area of track. For the same load, your contact pressure is more in case of wheel, and in case of track it is less. That means there will be more compaction in case of wheel, and hence there will be more rolling resistance. So that is the reason a track gives lesser rolling resistance as compared to your pneumatic wheel. Now if you compare with a rigid wheel, rolling resistance of track and rolling resistance of a towed rigid wheel. So what is the difference? Here we are not getting anything related to pressure. We are only getting in terms of W in case of in terms of diameter, and the suction weight B and the modulus of sinkage K. So it is difficult to compare. In fact, in the previous case these were similar, so that's why I made it very clear which one should give you lesser a rolling resistance. But if you look at now this equation, it is W raised to the power 2n plus 2 by 2n plus 1. This is very, very high, whereas it is only W raised to the power n plus 1 by n. So that itself gives you that yes, torque is better than rolling resistance of a rigid wheel. If the weight is same, then torque is going to give you lesser rolling resistance. Now, coming to the diameter, as we increase the diameter, the rolling resistance of towed rigid wheel reduces, because it is the negative. The power 2r is raised to the power minus n plus 1 by 2n plus 1. Here also the area is raised to the power minus n plus 1 by n. But the area which is obtained in case of a torque and the area which is obtained in case of a towed wheel, they are also different. The area of a torque is much higher than area of a towed rigid wheel. Towed rigid wheel. Because towed rigid wheels, its width cannot be more than say 5 centimeter, 2 inches, whereas torque width is much more than that. And length of the torque is, even if it is kept same as the diameter of the towed wheel, then definitely AT will be higher than ATRW. So that means torque rolling resistance of a torque is lesser than the rolling resistance of a rigid wheel. Now comparing the modulus of sinkage, because this is same for you cannot change the soil conditions. So it is K raised to the power minus 1 upon L, whereas it is K raised to the minus 1 upon 2n plus 1. So there is an advantage here. Advantage means minus 1 upon 2n plus 1. So this will give you a little higher resistance. The denominator is 2n plus 1, whereas it is in the denominator it is only 1 upon n. So that way, if you compare, again the rolling resistance of a torque can be seen to be lesser than the rolling resistance of a rigid wheel. So in total we can say the rolling resistance of a torque will be always lesser than the rolling resistance of a pneumatic wheel when they are operated in the same soil condition, in the same under same weight, and same is the case with rolling resistance of a rigid wheel. So in this lecture what I have done is I have tried to derive expression for rolling resistance of torque, then we tried to compare the rolling resistance of pneumatic wheel and rigid wheel expression which we derived earlier, and then we had a comparison individually, and then what we conclude from here is that rolling resistance of a torque is lesser than the rolling resistance of a pneumatic wheel or a rigid wheel. So briefly, if I conclude about this lecture, I have made an attempt where I derived the equation for predicting motion resistance of a torque. Then I tried to verify how it is different from pneumatic wheel or towed rigid wheel. And you can refer the book Theory of Ground Vehicles by Wong J.Y. Thank you.